Good morning. So in this video, we're going to be studying Newton's second law or Newton's law. So Newton's laws. And so what they tell you is basically what causes motion or what causes change in motion. And that's the main questions that we want to answer. And we are going to see that the idea is that force produces an acceleration which changes motion. And this is all summarized in the famous Newton's second law, which basically says F equals ma. And remember that ma is delta v over delta t. So basically a force produces a change in velocity, and that's how motion is changing. So this is Newton's second law, and this is the idea of this video this week. So let's start with answering the question. Not exactly, the question here is a little misstated, so I would write it better as what causes change in motion. So that's the question that we want to answer, right? So there are three laws that we use to explain this. These are called Newton's laws. So let's start with the first law. And the first law basically says that if an object is moving at a constant velocity, it will never change its motion if there's no forces. So if you have an example here of a car, and the only reason this car stops is because there's this wall here, and this wall applies a force on the car that stops the car. But if you look at the dummy continues moving, right? Because the force is only acting on the car, it's not acting on the dummy. Eventually, the wheel, the steering wheel, and this part of the car produces a force on the dummy that stops it. So Newton's first law says that an object continues moving at a constant speed if there's no forces. And then Newton's second law says that if there is a force acting on the object, then there will be a change in velocity. And we're going to state that later as an equation that helps us solve problems in a much better way. So let's look at forces. A force, we can think of it as a push or a pull. So here are examples of forces. You have a force applied to this ball, you have a force applied to this bag here, and you have a force applied to the football too. So a force acts on an object. So we have an object, and we typically have a force acting on the object. And that force produces a change in velocity, and therefore produces an acceleration. Every force has an agent. For instance, here, she is applying a force on that ball. He is applying a force on the back here, and the quarterback is applying a force on the football. So that's the agent who applies the force. A force is a vector. A force has a magnitude, the length of the vector, and a velocity. If I hit this ball this way, then it's going to move in this direction. But if I hit it horizontally, it's going to move in this direction. So the fact that there is a direction tells you that the force is a vector that has strength, magnitude, and has direction. So let's look at some type of forces. Contact forces are forces in which the two objects are in contact. For instance, this bat here applying a force to the baseball. Long-range forces. Those are forces in which there is no physical contact. For instance, gravity is a long-range force, and electricity and magnetism. Electricity and magnetism. So those are those are long range forces. So we're going to be drawing forces a lot to solve problems. So we're going to use that in a technique called free body diagrams later on. So to draw forces, we are going to use arrows to represent the vector force. Typically, the magnitude of the vector that will be proportional to the force magnitude, and then the direction of the vector represents the direction of the force. So that's and the force is going to be drawn. Let's say we have a box here, and then we have somebody pushing the box. So then we're going to draw a force on the box that pushes the box. So let's look at some examples of force vectors here. So we have a tension force. So then that'll be a force here, and tensions we typically use the letter T. We have a spring force, right? So the spring force also pushes that way. And then so we can represent that as force from the spring. And we have gravity. Gravity is the weight, and we normally represent that as a W. So forces act on one object at a time, right? So here we have two forces acting on this box. So one points that way, the other points that way. And it is a fact of nature that we can add these forces. So we have these two forces here. We add them, and we get this here. And this concept is very important. This is the net force. This is what appears in Newton's second law. The net force, the resultant force, the addition of all the forces acting on an object, that's what is important. So let's look at some forces, some common forces. So we have weight. Weight is the force due to the attraction from the entire Earth on an object. So the weight always pushes down, and we represent that with the letter W. We have spring forces. We have objects connected to springs, and then they move back and forth. These are spring forces. We have tension forces when we have ropes and strings. Then we say the force is a tension, and we use the letter T to represent those forces. We have normal forces, right? If the table wasn't here, this book would go all the way down to the center of Earth, right? Eventually. So the only thing that is stopping this book is a force due to the table on the book. So if you draw the book here, there is the weight, right? So that force pushes down, and there is a normal force, and that force pushes up, and these two cancel each other, so the book doesn't fall completely. So this is a very important concept, sometimes confusing. So we are going to look at some normal forces in more detail. So here is a skier, right? So then this is an inclined plane, right? So there is the weight on the skier, but there is also a normal force which is normal, perpendicular to the surface, right? So perpendicular to the surface means this. So this is the normal force, and this is the weight. Friction is a force that opposes the motion of the object. There's two types of friction: kinetic friction when the object is moving, and static friction. We're going to work with this. Kinetic friction basically is the friction that slows down an object that is moving. Static friction is the friction that you have to overcome to make the object move in the first place. For instance, if this object is at rest, then she has to apply the force to get it to move, right? So that initial force that she has to apply overcomes the static friction, and we denote that by Fs. Now this boy here, he's moving with a velocity v, right? So there is a friction between the ice and the sled. It's a small force, and we denote that by Fk. That's kinetic friction. Drag is the friction due to the air around you. That's That's a force that we would apply when we have cars, we have rockets, we have airplanes. So in many cases, when we are moving slow, we can neglect the air resistance. The drag is proportional to the velocity. The faster you go, the more drag you have. And in some problems, we're going to have rockets, and there is a force that we're going to attach to the rocket that makes the rocket move, and that is the thrust. So that is the force that makes a rocket go up. Electric and magnetic forces, we're not going to be looking too many of those, but those are long-range forces like gravity. And so these are the forces due to electric charges on each other or magnetic charges on each other. So this is the list of general forces. So if you have a force and you don't know how to classify it, we use F. We have weight, we have a spring force, tension, normal force, static friction, kinetic friction, drag, and the F of the rocket. So you don't need to memorize this. It'll be common sense to know what to use in each case.